The last example in this section is example 7. Find the gradient of the curve x equals y squared minus 4y at x equals 5. This is actually the same question that we just did, but with a different, I suppose, variable that we're looking at, so x instead of y. We do this similarly though, so we know when we did this worked example we had, and we'll just do it nice and quick, x equals y squared minus 4y. We took the derivative with respect to y of both sides, and we did that because the function on the left is all with respect to y. We then had dx dy equals 2y, so differentiating with respect to y, minus 4. And flipping both sides, flip, we have dy dx, the gradient function, equaled y over 1 over 2y minus 4. So that's our gradient function. And the question now asks, what happens at x equals 5? Now the key here is to recognise that you have no x's here and to not go, well, I'm in trouble, what can I do? What you need to think of is, well, I've got y, how can I turn an x into a y? Well, what you can do is you can use the function itself. So to do that, we then substitute, so sub x equals 5 into the function x equals y squared minus 4y. So what we then have is we have 5 equals y squared minus 4y. Now you can solve this as a quadratic, or if you want to, you can use your CAS. So either way, I'll solve this as a quadratic because we should know how to do this by hand as well. So take the 5 over to this side equals 0. This factorises nicely into y minus 5 and y plus 1 to give us the minus 4. So that means that our solutions are going to be y equals 5 and y equals negative 1. So what you can do is actually look at two cases that happen here at x equals 5. So when y equals 5, we actually have our gradient function, dy dx, equals 1 over 2 times 5 minus 4, which is 1 over 10 minus 4, which is 1 over 6. And that's positive. When y equals negative 1, your gradient function is going to be 1 over 2 times y is negative 1, minus 4. And this is going to be 1 over negative 2 minus 4, which is negative 6. Now the thing that you notice here is that both of these things, or these gradients, are happening at the same x value. So at x equals 5. So at 5, the gradient equals a sixth. Why is it 5, 5? Well, this is when x equals 5 and when y equals 5, because in both of these cases x equals 5, yeah? That's how we got to this point, to these two y values. And the other coordinate would be when x equals 5 and when y equals 1, the gradient is negative a sixth. And you might think, how is that possible? This particular graph here, on the next page, we can actually see what that looks like. And I'm just going to copy this result so we can try and understand what's happening. These are the graphs. I've taken this out of your textbook so you can see. This graph here, y equals x squared minus 4x, is actually the inverse, effectively, of this graph here, just swapping x and y. And you'll notice here that the graph x equals y squared minus 4y, which is the graph we were just looking at, oops, and I'll just highlight that there. That's the graph we just worked on. At the point x equals 5, check it out, you've actually got 2 points, point B and point C. And at those 2 points, the graph is actually doing two different things. The first thing you'll notice here is at this point, point C, this is the negative point here. So this is actually this guy. Okay, 5 minus 1, that's C. The gradient is negative a sixth, and it's a negative gradient because if I draw a tangent, and I'll just do this with the line here, a tangent line through that point, it will be a negative slope. So this particular point here, this is point C, and we have a negative slope, and you can see that on the graph. Now the other point you can see here, point B, that's at the point 5, 5 in our function. You can see there's 5 and there's 5, and the thing you'll notice about the slope there is that the slope is going up, so we actually have a positive slope. But because this function is symmetric, the slope, even though it's positive, is still the same, basically magnitude, I suppose, as the slope down here. So they're mirror images of one another. So that's why one is 1/6 and the other is the negative of that value, 1/6. So the fact here is that you have 2 points at x equals 5, which you find by solving this equation for y. So plug in x equals 5, get your y values. You actually have, in this case, 2 y values for that particular x. Oops, 2 y values. Then once you've got those y values, use those y values and put them into your gradient function, because your gradient function is given in terms of y only. So put those solutions, y equals 5 and y equals -1, put them both into your gradient function to find what the gradient is, and you can then express the gradient at each of those points where x equals 5 with the 2 different y values as a particular gradient, as either 1/6 or as -1/6 in this case.